So 11, the density of an object is 7.21 grams per centimeters cubed. What is the density of this object expressed in kilograms meters cubed? Oh my God, I almost keep saying squared. Sorry, I was doing math earlier. So first things first, I'm the realist. No, I'm kidding. We're gonna convert basically this. Centimeters cubed. We're changing that to this, right? You agree? That's literally what they want us to do. So we're gonna do this part first. So you know what? Let's just do this an easier way. So check this out. I like to break rules, guys. I remember when I took chemistry, I just broke a lot of rules. So we want to get this guy, specifically these units, to that, right? The grams over centimeters cubed, grams to centimeters cubed. We got to get it to kilograms over meters cubed. That's not really hard at all. Let me tell you how we're going to do it. So this is the conversion factor. 1 grams over centimeters cubed is equal, okay, is equal to 1,000 kilograms meters cubed. So this is the conversion factor we're doing. So check this out. So 2 times, we're going to use this guy right here. So in the bottom, we're going to obviously put 1 grams centimeters cubed. Sorry, I know that stick curved a little bit. That was not intentional. We got 1,000 kilograms meters cubed on the top. So the grams centimeters cubed cancel out. We got 7.21 times 1,000, which all you got to do is 1, 2, 3, boom. So the answer is 7,210 kilograms meters cubed, because that's what we have left over, these units. Those ones got canceled out. So that would be the final answer. Yeah, it is that easy. I know the way your teacher probably wants you to do it is a longer way where you actually break down everything. But honestly, if you know stuff like this, it's a shortcut basically, and it's a very effective one. Why are you gonna waste time doing, let's say you had a number, you can convert, and you get your answer. If I could do all of this in just one simple conversion to get my answer, you feel me? That's just me though. Everyone's different. I just like to make, I like to work smart, not hard, you know? Life's too short. So 12. Oh my God, this is a mouthful. So there are 2 different rocks. There's only one kind of rock. I like The Rock. He's a good actor. The first rock has a volume of 15 centimeters cubed and a mass of 45 grams. The second rock, blah, blah, blah. Basically, the volume's 30 and it weighs 60 grams. What is the density of each rock? If both rocks had the same volume, which one would be heavier? Interesting. So let's do this. Let's break this off. Got rock 1. Let's put over here rock 2. So we are going to use this formula, density equals mass over volume. But remember, so for rock 1, density, because we need to find density for both of them, the mass is 45 grams. The volume is 15 centimeters cubed. That equals 3 grams over centimeters cubed, right? Because gram over centimeter cubed, that becomes the unit. And then the math portion, 45 divided by 15 is 3. Found the density of rock 1. Let's find the density of rock 2. I like the movie Jumanji. I tried thinking I was going to hate it, but it was a good movie. I think The Rock, just all the actors in it were pretty good. So we got, for the second rock, is 60 grams is the weight. The volume is 30 centimeters cubed. So just using basic math first, cancel out the zeros. 3 times 2 equals 6, so 2 grams over centimeters cubed. This is the density for rock number 2. Now, the next part, it doesn't involve any math. It's just freaking logic, common sense, if you will. What is the density of each rock? Boom, found it. If both rocks had the same volume, which one would be heavier? Volume has nothing to do with it. Just think about it. How much did the first rock weigh? 45 grams, okay? First rock is that heavy, 45 grams. You don't even need to know what grams it is, to be quite honest. You just need to know 45. The second rock weighed 60 grams. Now, logically, guys, what do you think weighs more? Something that is 60 grams or 45 grams? Or let's do it in pounds. What weighs more, 60 pounds or 45 pounds? 60 pounds, right? Rock 2 is clearly heavier, even if the volumes were to be different. It's kind of like this. Let's say we had 2 pieces of paper, right? 2 pieces of paper. I get the second paper and I crumble it up. This is my crumbled up paper. And this is the first paper. Does this one weigh more? No, it doesn't. They weigh the same, right? But let's pretend, for the sake of argument, hope you guys copy that down. Paper 1 had maybe like a couple drops of water, so let's pretend this is wet. Just wet on the corner. Paper 2 is still dry. You would agree that paper 1 is heavier because it has something else added to it. But if we had 2 same pieces of paper, like your line paper you guys use at school, and I crumbled up one, and one became a crumbled up piece of paper, they still weigh the same. Volume is irrelevant. What is more relevant is the initial mass of both items. So that is why the second rock is heavier. Just look at that. Volume has nothing to do with it. And even if the volume, mathematically, it does have something to do with it, but just think about it. You're going to do something with this number. So that would be it. Let's go to number 13. A graduated cylinder contains 5 liquids, each a different color. The color and density of it follows. Okay, so we have gold. We're going to do a G. It's 4 grams per centimeter cubed. They're all grams per milliliter. They're all the same thing, so we're good. So